String theory is out there. It exists. We can play with it. The universe is a symphony of strings. That's my equation. I'm the creator of string field theory. Personally, I do believe that there are intelligent life forms in the universe. Can we visit them? You need the Planck energy to do this. When we look at UFO sightings, about 5% of them make the hair on your head stand up. But it's possible to attain digital immortality. The other kind of immortality is much more difficult, and that is organic immortality, that your physical being lives forever. Let's say I turn off quantum mechanics. Let's say, boom, by magic, I make quantum mechanics disappear. What happens? I disappear. Big bangs happen all the time. Even as we are speaking, universes are being created. And so the only way to escape the ultimate death of the universe might be to leave the universe.
Chapter number 1, String Theory.
Is string theory correct? I don't know. However, it's the only game in town. There's no other rival theory that has matched the sophistication of string theory. And string theory, very simply, is a theory of music. Think of music. How many notes are there in a violin string? A, B flat, C sharp, just like subatomic particles. So this, for example, would be an electron. This would be a proton, a neutron, neutrinos. They're nothing but different vibrations of a tiny string. And so what are subatomic particles? Subatomic particles are basically notes created by a vibrating string. Well, what is physics? Physics is the laws of harmony of these vibrating strings. What is chemistry? Chemistry is the theory of interacting strings, which create molecules and matter. What is the universe? The universe is a symphony of strings. And then what is the mind of God that Albert Einstein wrote about eloquently for the last 30 years of his life? What would be the mind of God? The mind of God would be cosmic music resonating through 11-dimensional hyperspace. That would be the mind of God.
Chapter number 2, Grand Unification Theory.
Many scientists believe that the ultimate goal of physics is unification, to unite the left hand and the right hand of the universe, to unite quantum mechanics with relativity, to create a relativistic theory of quantum mechanics. That is the ultimate goal. So far, the only theory which has survived all challenges is string theory. Now, that doesn't mean it's correct, because we can't test the theory, because the theory talks about particles that have energies far beyond anything that we can create on the planet Earth. In other words, we are too primitive to test string theory. String theory is out there. It exists. We can play with it, but we can't test it because it talks about universes beyond our everyday comprehension. So some people say, well, maybe I don't like string theory. Give me an alternative. And the truth is, there is none. There is no alternative to string theory. Many people have tried. The greatest minds of science, people like Heisenberg and Wolfgang Pauli and Schrödinger, they all tried. They all tried to unite quantum mechanics and relativity, but they failed. String theory is the only survivor. One of the goals of physics is to find a unifying principle, a principle which will allow us to explain so many things. And for me, it was a question when I realized that string theory is a theory of music. What paradigm of human behavior allows us to explain so many things about the world? Music. Music captures emotions. It captures feelings. It can create new worlds. And it is the only paradigm that we have of everyday life that allows us to have a unified understanding of the world around us. The world of emotions, the world of feelings, all of it encapsulated in vibrating strings. And so it was the realization that vibrating strings is a paradigm. In fact, the only paradigm that is rich enough to explain the entire universe. Some people say, well, string theory is nice, but so what? I mean, what's in it for me? What's in it for numero uno? Why should I care about string theory? And the answer is that everything around us is a byproduct of string theory, including life, including the richness of our world around us. Think of photosynthesis. Photosynthesis is what makes life possible. How do we get carbon dioxide, sunlight, and create oxygen and food from it? This is an amazing feat of nature. And yet, what makes it possible? Quantum mechanics. Because without quantum mechanics, atoms fly apart. Think of a solar system, for example. You have planets going around the sun, and let's say we have two solar systems that collide. What happens? Boom! They fly in all directions because the theory of gravity does not give you stability. A theory of gravity cannot create stable matter. Solar systems will collide and have collided and will basically throw planets apart. In other words, classical physics is unstable. Newtonian physics is inherently unstable. You cannot create a universe out of Newton's theory. However, gravity, which is quantum mechanical, can create waves, waves of stability. All of a sudden you get molecules. All of a sudden you get tremendous molecules like DNA composing of thousands of atoms. In a Newtonian universe, it would all disintegrate. Photosynthesis is impossible. Life is impossible in a classical world. In a classical world where particles go around other particles, what do when they bump into each other? They fly apart. In other words, quantum mechanics gives you stability. It gives you stable atoms, atoms which give you life, atoms which give our body. Let's say I turn off quantum mechanics. Let's say, boom, by magic, I make quantum mechanics disappear. What happens? I disappear. I dissolve. In other words, we are byproducts of quantum mechanics. Without quantum mechanics, we would dissolve. Quantum mechanics is what holds atoms together. Newtonian mechanics of Isaac Newton is not sufficient to create stable matter. Look at solar systems. If solar systems collide, they fling planets apart. Things are unstable. So in other words, why do we need quantum mechanics? To create stable matter. Without quantum mechanics, you dissolve. You dissolve in an ocean of mist. You dissolve in a mist of subatomic particles.
Do you feel you are the father of some parts of string theory?
When I first worked on string theory in 1968, it was a random bunch of equations. Marvelous equations, but what relationship was there between all these equations? There has to be a language that unifies all these equations. And in physics, the language is called field theory. So I said to myself, there's got to be a field theory of strings that unifies all these equations of string theory. That's my equation. I'm the creator of string field theory, which is a way to unify all the equations that make what is called string theory. So some people say, well, what is string theory? It's an equation 1 inch long. How do I know that? That's my equation.
Do you remember the time of this idea? Did you invented this idea, the moment, the time, in a university or somewhere you've been there?
I was teaching electromagnetism to undergraduate students at the university one day. The same experiment over and over again with electricity. But then I said to myself, now wait a minute, the lines of force of electricity is like strings. That there is a field theory of electricity. Therefore, there should be a field theory of strings. And so I said to myself, the advantage of this is that I would have one equation, an equation no more than 1 inch long, that would give all of string theory, rather than hundreds of disjointed equations and rules of thumb. And so that's my contribution, and that is to create a unified theory of string theory.
Human consciousness also could be born on the quantum level.
I don't know exactly how the brain is put together. It's one of the great mysteries of science. Some people think that ordinary mechanics can explain the brain using transistors and circuits, but maybe that's not rich enough. Maybe quantum mechanics has a role to play. I personally think that yes, quantum mechanics probably does have a role to play because of something called free will. What is free will? Free will is the ability for us to do creative things on our own without somebody telling us, without it being scripted ahead of time. We have free will, but a robot does not. A robot is mechanical, deterministic. Once you turn it on, it just does what it does, the same thing over and over and over again. So artificial intelligence based on robots, okay, do not have free will. We think we have free will. Now, do I really have free will? I don't know. I think I do. I think I am responsible for my actions, so that free will does exist. But I'm not sure. So what is the missing ingredient? Quantum mechanics. In other words, if my brain is digital, I have no free will. I am a robot. With quantum mechanics, I have uncertainty. And uncertainty makes creativity, makes thinking, consciousness possible. So in other words, consciousness could be a byproduct of quantum mechanics.
Chapter number 3. Quantum world versus physical world.
After 2,000 years of investigating the nature of matter and energy, we've come up with two great formalisms. One is the theory of the very big, that is, general relativity, which gives us the Big Bang and quasars and all the wonders of the universe. The theory of the very big. Then there's the theory of the very small, that is, the quantum theory. Now the problem is Mother Nature has a left hand and a right hand, quantum mechanics and relativity, but these two theories are incompatible. You put them together and what happens? They explode. And that is the greatest problem in all of physics. How to unify the theory of the very big, that is relativity, with the theory of the very small, which is the quantum theory. So at the present time, the only construct that we have coming from mathematics that unites quantum mechanics with relativity is string theory. Very controversial. We don't know whether it's correct or not because we can't test the theory, but so far is the only game in town. You take a classical theory, a theory of Einstein, and then you add quantum corrections to it, and the theory is finite. People have tried to do this for decades and have failed. Every time you take relativity and try to add quantum mechanics to it, the theory blows up. Now, Sir Roger Penrose would like to do the opposite. He would like to gravitize quantum mechanics. Now, I wish him well. I wish that he becomes successful in this pursuit, but we'll wait and see. The proof is in the pudding. So far, the only theory which allows you to unify these two great branches is string theory. The greatest challenge in all of physics is the unification of the two great theories, quantum mechanics and relativity. The only theory which can do this at the present time is string theory. But string theory has a challenge, and that is, why do we have so many string theories? It turns out that there's no one solution of string theory. Similar to Newton's laws of gravity. How many solutions of Newton's laws of gravity are there? Infinite number. Cannonballs, rackets, tennis, swimming, asteroids, suns, stars. They're all solutions of Newton's theory. So how many solutions of Newton's theory are there? An infinite number. Same thing applies to string theory. String theory, like Newton's theory, has an infinite number of solutions. But the question is, which one is ours? That is the number one question facing string theory. Of all the strings that exist, they are beautiful, they work, but which one describes our universe? We don't know, because we don't know that much about the Big Bang. Once we understand the creation of the universe, then we can test it against string theory. But right now, we do not understand the Big Bang.
Chapter number 4, Multiverse Theory.
I personally think, and this is just my own feeling, that there is a multiverse of universes. Think of a bubble. A bubble can collide with other bubbles, creating a bigger bubble. Or a bubble can fission in half to create two smaller bubbles. That's the Big Bang. So in other words, the Big Bang is when these bubbles bump into other bubbles or collide. This is the multiverse theory. The theory that there's not just one universe, but an infinite collection of these universes. And that at the beginning of time, one of these universes came out and this bubble expanded to create our universe. But there are other bubbles out there, other bubbles that can also expand in a multiverse of universes. And that's why string theory has an infinite number of solutions, because these solutions are different ways in which you can have Big Bangs. So in other words, Big Bangs happen all the time. Even as we are speaking, universes are being created.
But there is no evidences for multiverse theories.
The weak part of this whole theory is that it's all simply a theory at the present time. We want proof. We want concrete proof, and that may come from something called dark matter. You see, string theory is not just a theory of electrons and protons and neutrons. It's a theory of music with higher notes. Notes beyond the electron, beyond the proton, and we think that could be dark matter. Dark matter makes up most of the matter of the universe. We think that atoms make up the universe, right? Wrong. We realize now that most of the universe is dark. Most of the universe is not made out of atoms. It's made out of a new substance, which we think is the next octave of the string. How many octaves does a string have? An infinite number. So the number of universes, the number of forms of matter could be infinite. That could be dark matter. Dark matter we investigate with our telescopes, our instruments. This is not science fiction. Most of the universe is made out of dark matter. And string theory is the only theory rich enough to explain not just neutrons and protons, but dark matter as well. Some people say that black holes look like a hole in space. And if there's a hole in space, then what does it connect to? Well, the first person to talk about this was Albert Einstein. In 1935, Albert Einstein wrote the first paper on a black hole being a gateway to another universe. So think of a funnel that looks like this, that has a neck, and then Einstein put two funnels together to create another bubble. In other words, on the other side of a black hole is another black hole. Two black holes joined together at the hip. A picture which was introduced by Einstein himself. Today we call them Einstein-Rosen bridges, bridges between universes. First of all, some people say, isn't this science fiction, a black hole being a gateway to another universe? Well, of course. We're dealing with science beyond what is testable with our instruments today. So by definition, it's going to be science fiction. But sometimes science fiction becomes science fact. Now, if there are gateways to other universes, then could this be a solution to the ultimate death of the universe itself? The universe is expanding. What is it expanding into? How long will this expansion take place? Some people think that the expansion of the universe will go on forever. Things will get colder and colder with time. and everything will eventually freeze to death. Because physics is not just a theory of the beginning, it's also a theory of the end. So for example, how will the Earth die? The Earth will die about 5 billion years from now when it is eaten up by the sun. How will the sun die? The sun will not die in fire. The sun will die in ice. The sun will freeze over billions of years from now. And then what about the stars that we see twinkling in the universe? They will eventually exhaust their nuclear fire, and they will also turn to ice. And then the big question is, will the universe die in fire, or will the universe die in ice? I don't know the answer to this, but if the multiverse theory is correct, it means that our universe will probably die in ice, and we will all freeze to death at some distant point in the universe. And so the only way to escape the ultimate death of the universe might be to leave the universe, to create an artificial wormhole, a gateway to another universe, a bubble, a lifeboat, to take intelligent life from a dying old universe and to repopulate a young, rich universe where we can mess up that universe as well.
Have you ever think about the simulation theory?
When people see the movie The Matrix, people wonder, is it really just a movie? Or maybe we are puppets. We are dancing in a world where somebody is pulling the strings and somebody hit the play button and then the universe unfolds and then you push the stop button and everything stops. Is that a possibility? Well, I think not. Because of the fact that quantum mechanics gives us different alternate universes, and this multiverse theory, therefore, is untestable. You don't know for sure whether or not quantum mechanics can give you all these different kinds of universes that are fictitious and that were all scripted ahead of time. In other words, it's an untestable theory. So I personally think that it probably violates quantum mechanics also. It violates the uncertainty principle. The theory of the matrix is a theory without quantum mechanics. It's a Newtonian type theory. So the universe is not Newtonian. The universe is quantum mechanical. And therefore I think that we do not live in a matrix, that this conversation was not preordained.
Chapter number 6, UFO sightings.
When we look at UFO sightings, realize that maybe 95% of them can be dismissed. But about 5% of them make the hair on your head stand up. About 5% of these times, we're dealing with sightings that are done by multiple witnesses with multiple technologies. That's the gold standard. The gold standard for looking for intelligent life in the universe is not looking just for flying saucers. No, you want something more than that. So what we have here is we have volumes and volumes of sightings, but no tangible proof. No one has been able to find alien technology or to capture an alien. This is something that has not yet happened. And so some people email me and say that they know the aliens are here because they've been in their flying saucers, they've been kidnapped. They know that the aliens are here. I tell them that the next time they're kidnapped by an alien, for God's sake, steal something. I don't care whether it's an alien chip, an alien hammer, an alien transistor, steal something, because then you will have tangible proof that you've been in their flying saucer. So far, we have no proof. We have not yet met the gold standard. We do not have reproducible evidence, multiple sightings by multiple modes that give you unquestioned access to a civilization with an advanced technology. At the present time, we do not think that superliminal rocket ships are possible. rocket ships that go faster than the speed of light. However, warp drive may be possible. And there are two kinds of warp drives. Let's say you want to walk across a carpet. One way to walk across a carpet is to squeeze the carpet so that you simply hop across. So that is one way, a shortcut from point A to point B, rather than walking from point A to point B. The other way is to get a scissors and to create a shortcut that allows you to go from A to B. The second method is the wormhole method. That is, punching a hole in space and time. The first is the Alcubierre drive. Alcubierre, an acquaintance of mine, is a physicist who found a new solution to Einstein's equations. We thought we had a handle on solutions to Einstein's equations, but he found a solution that allowed you to go faster than the speed of light. Now, how is that possible? By warping space and time. And it is consistent with Einstein's theory. So what's the catch? Why don't we have warp drive by punching a hole through space and time, or by using the Alcubierre drive? And the answer is energy. You need the Planck energy to do this. And we are far, far from being able to harness the Planck energy. Realize that with our atom smashers can only get up to trillions of electron volts. But the Planck energy is 10 to the 19 billion electron volts. That's 1 with 19 zeros after it. That is an energy that is for a type 3 civilization. Now, a type 3 civilization may be able to access this energy. You do the math, and you see that, yes, they would have the energy to warp space and time, to perhaps even build a time machine, who knows? But it's not for us. We are a type 0 civilization. We don't even rank on the scale of civilizations. The latest calculation I've seen shows that we are perhaps 0.7 in terms of our technology. A type 1 allows you to go across the solar system. We are 0.7 in terms of our technology. There was a statement made just recently by a person that has access to many of these secret files, that not just us interacting with flying saucers in the sky, but flying saucers that have crashed, and that bodies that are being examined. But then he was asked before Congress for evidence, hard proof, that is alien technology, alien bodies. And at that point, this person says, I don't have it. I talk to people who say they've had it, but I have not personally seen the evidence. And so my personal point of view is, let's keep an open mind. Maybe not. But where's the beef? You want hard evidence. It's not enough to simply say that a type 3 civilization allows you to conquer the galaxy. It's not enough. You want hard proof, and we don't have that yet. That was a big disappointment. Personally, I think there are aliens out there. Personally, I do believe that there are intelligent life forms in the universe, that we're not the only game in town. The question is, can we visit them, or have they visited us? That's the question. And so that is no longer just a question of, I saw something in the sky. Maybe you did, maybe you didn't. You want to have proof. And if there was something up there in the sky, then how did they get here? You begin to realize that a type 1, even a type 2 civilization would have difficulty reaching the Earth. So for them to reach us, they would perhaps be type 3. A type 3 civilization would be about 100,000 years more advanced than civilization here on the Earth. Growing at an exponential rate, they would reach the Planck energy on the order of 100,000 years. At that point, we can discuss, therefore, whether or not these aliens actually exist. And then the next question is, if they exist, how come they don't visit us? Let's say you're walking down a country road and you meet a deer and you try to talk to the deer. The deer seems to be interested in you, but eventually you get bored because the deer doesn't talk back to you. It's just a one-way conversation. And the deer gets eventually scared and hops away. So I think that if we meet intelligent beings from outer space, they may think of us being rather boring. I mean, what do we have to offer them? Gold, silver, but realize that gold, silver probably have no practical purpose in their civilization. So in other words, we have nothing to offer them. And that's why I think that if they ever do visit us, they would consider us to be a curiosity. They would study us. They would perhaps study us, perhaps analyze us, but after a while they'd be rather bored because there's nothing to be gained. I mean, how often do you try to interact with animals to learn the secrets of their eating behavior, their secrets of their mating behavior? I mean, do you spend a lot of time studying animals? We don't. So why should they?
How many dimensions we have?
When I was a child, I used to visit the Japanese tea garden in San Francisco where there are fish swimming in a shallow pond. And then I imagined that there was a scientist fish in that pond. The scientist fish would say, "Bah, humbug. There's no world beyond the pond. The pond is the universe. We are the only beings in the pond because that's where life is possible. There's nothing beyond the pond." And then I said to myself, if I reached down and grabbed the scientist fish, lifted the scientist fish into the third dimension, what would he see? He would see beings moving without fins, a new law of physics. Beings moving and eating without the benefit of water technology, a new law of biology. And then I put the fish back in the pond. What would the fish say? The fish would say, "My God, there's a whole universe, a universe beyond the second dimension, a universe in the third dimension with new laws of physics, new laws of biology." Well, today, I think that we
Are the fish.
are the fish. We spend all our time not just in 2 dimensions, but in 3 dimensions, thinking that that's all there is. That you can move forward, backward, left, right, up, down, but that's all there is. Well, today I think that we are the fish, because if string theory is correct, and who knows for sure, if string theory is correct, there are 11 dimensions. 11 dimensions in hyperspace. Well, so far, string theory is stable only in 10 and 11 dimensions. It's unstable in 13, 14, 15 dimensions. So it is the only theory known to science that selects out its own dimensionality. Newton's laws can exist in any dimension of space and time. You can write Newton's laws in 15 dimensions if you want, okay? But we happen to live in 3. Why? We don't know. We just know that the laws of physics that we've devised so far are in 3 dimensions because that's what we're familiar with. No particular reason for that. It's just that it's convenient to write equations in 3 dimensions. But string theory forces us to believe that the Big Bang was a bang that took place in 11 dimensions. It was not just an ordinary 3-dimensional bang. It was a 11-dimensional bang, and that our universe is a bubble. One bubble that came out of this bang that happened to be in 3 dimensions.
Chapter number 8. Vision of the Future.
Let's say that one day you're allowed to meet your ancestor who lived a few hundred years from now, and you were to talk to your ancestor about airplanes, about rockets, about computers. What would your ancestor think? Your ancestor would think, "You're crazy. What? Images from the ether? What? Journeying to the moon? What? Computers that can calculate 1,000,000 times faster than the human brain? What are you talking about?" So our ancestors would think that we live in a world of science fiction. We live in a world of trains and rockets and atomic bombs that our ancestors would think is impossible. So if we were to visit one of our children, our great-great-great-grandchildren, a few hundred years from now, what would we think of them? You see, our ancestors would think of us being wizards, wizards that can create images out of nowhere, wizards that can communicate around the world instantaneously. That's what our ancestors would think of us, that we are wizards. What would we think of our children's children's children? We would think of them as being gods. And so, in other words, the world of the future is a world similar to mythology, a world of the gods. So our great-great-great-grandkids, they will live in a world where we can control life, where we can control matter and energy, things that are impossible today, but is the plaything of gods.
Uncontrolled reality, that's our future.
That could be it. That we would be able to control reality, control life, control matter. We would think of that today as the world of magicians and voodoo artists. But that could be the world of our great-great-great-grandkids.
How this ordinary day could look like.
A day when? What time period?
In 2050.
The question that is often asked is, okay, if you're a scientist, then predict the future. Tell me what the future is going to look like. Well, first of all, I don't know what the future is going to look like. But what I can say is I think that we can make educated guesses. Educated guesses because we know the trajectory of physics and chemistry. You see, our ancestors lived in a world of magic, a world of witchcraft. There were no rules. There was no equations, no principles to guide them. Today we have the principles. We have the equations. We have the framework. That doesn't mean we can accurately predict the future, but we can make intelligent guesses. So for example, computers. We would know that computers will be quantum mechanical. And as a consequence, they would be millions of times more powerful than what we have today. And therefore, artificial intelligence could become a reality. In which case, we may exist in a world where artificial intelligence is the norm. The digital world is deterministic. The digital world is Newtonian. But a quantum computer exists in a world of quantum mechanics. It exists in a world of infinite states. And these already exist. We have quantum computers. They're not ready for prime time yet. But the ones that we've built so far are millions of times more powerful than any digital computer today. The problem is they can only work on one problem at a time. They're not all-purpose, like a digital computer today can add, subtract, do many things simultaneously. A quantum computer can only do one quantum mechanical operation at a given time. But they are, in principle, millions of times more powerful than any digital computer. And many people think that could be the future. The future is when we have quantum computers that are millions of times more powerful than anything on your desktop today. I think 100 years from now, our descendants will live like the Greek gods of the ancient times. They will be able to manipulate matter, manipulate energy, manipulate life itself in a way that we would consider to be magic. We would be able to manipulate our genome. Today we can manipulate our genome one gene at a time. In the future we'll be able to manipulate our genome perhaps as an entire quantity, not just one gene at a time, and able therefore to alter the course of life itself. So in other words, instead of using this technology to heal, to be able to cure diseases, we may be able to alter ourselves, to create ourselves to populate the universe. In other words, we may ultimately change the destiny of the human race itself. For example, if we colonize Mars, realized that Mars has a different gravitational field, different atmosphere, different temperature. Instead of trying to readapt Mars, why not readapt ourselves? To remodify ourselves so that we can survive in these environments around the universe. And so instead of looking at planets with hostile environments, why not alter ourselves so that we can survive in these? This is science fiction, but it's possible. One of the great frontiers is the human brain. Throughout history, the human brain was basically a black box. And just recently, we're beginning to understand that there are mechanical analogs to the thinking process. And eventually, we'll realize that the brain is in part quantum mechanical. And this is where quantum computers come in. Quantum computers already exist. And they, in some sense, compute somewhat similar to what the human brain would compute if it's quantum mechanical. And so we're talking about a new era where we can change ourselves. Now, this means that the question of immortality is on the table. There are two kinds of immortality. One is digital immortality, and one is organic immortality. Digital immortality is when you create a clone of yourself that is mechanical, that has basically many of your memories, thought patterns, and looks like you. And the first generation of these digital immortals has already existed. What we do is we create an image of yourself that moves and talks, and you talk to this image. And this image is accesses a tape recorder that has interviewed you and got your entire biography. This was done with William Shatner of Star Trek fame. For several days, he was interviewed about his life, his ideas, his thoughts, his history. And it was put into an image of him that will live forever. So this is digital immortality, something which is attainable today, in fact, rather primitive today, but it's possible to attain digital immortality so that you can have a conversation with your great-great-great-great-great-great-great-grandkids about life in the 21st century. Digital immortality is when you can keep your secrets to yourself. Because what you do is you speak in front of a tape recorder that creates an image of you talking in real time and people asking you questions and you answering them. So digital immortality is something that is attainable today, and it would make your thoughts visible forever, and you would be able to have a conversation with your great-great-great-great-great-great-great-grandkids, okay? But if you have secrets, you can keep your secrets to yourself. So your secrets will die with you. The other kind of immortality is much more difficult, and that is organic immortality, that your physical being lives forever. And there have been several proposals for this. One proposal is to basically digitize the brain itself. You take a brain of a mosquito or a fly, and you can clone it, and you can create a copy of it and dissect it. This has been done already. The world's record for dissecting the brain of an insect is 100,000. 100,000 neurons will allow you to dissect neuron for neuron the brain of an insect. Our brain has 100 billion neurons, not just 100,000 neurons, but it's only a matter of time before we can digitize the human brain itself, not just 100,000 neurons, but 100 billion neurons. That's one way to do it. Another way to do it is to place yourself on a stretcher, and sitting next to you is a robot. When the brain is then exposed, neuron for neuron, another duplicate is created inside the robot. And then these neurons are then hooked up to each other one by one. Now, of course, this is possible, but not practical with today's technology. We cannot manipulate neuron for neuron the architecture of the human brain. But that's a technical problem. So we're talking about putting the putting the brain into a computer or a computer into a brain. And so the two become the same, basically. This is all possible, and it's been looked at. Of course, it would take centuries for us to be able to do this process, but it's possible. We can now connect the human brain to a laptop computer and have the laptop computer execute many patterns that are considered to be human-like. This has been done because there have been so many GIs wounded in Afghanistan and Iraq that the United States military has made it a priority to have these heroes of warfare be able to control a computer so they can walk, they can talk, they can perform many human functions even though they are functionally paralyzed. And so this is progress today, that using computers it's possible to interface the human brain with the laptop computer, which in turn can control your movements. This was done for the Olympics. The Olympics that took place in Sao Paulo, Brazil a few years ago was initiated by a man who was totally paralyzed. Here was a man totally paralyzed. He was put into a skeleton, a digital skeleton that was connected to his brain. Therefore, he was able to stand up and walk. He was totally paralyzed, but by thinking, he was able to control the exoskeleton, which would allow him to walk, and he initiated the World Cup soccer games in Sao Paulo, Brazil, even though he was totally paralyzed. Now that's today. In the future, we could become supermen or superwomen. Well, right now we're at the early stages of this. All we can do is take paralyzed people and give them back the gift of movement. That's today. In the future, we may be able to give them super movements. That is the ability to move things that only a robot could create. In other words, these people would be superhuman. And one possibility is that these superhumans would then colonize Mars and begin to colonize the universe because they are superhuman in their physique.
Upgraded version of us.
That's right. Now, this is possible, I think, within 100 years or so. Now let's take it to 1,000 years. How could we then explore the universe 1,000 years from now? I think it's possible that at that point, we'll be able to digitize ourselves, put our thinking process into software, put the software into a rocket, and shoot the rocket throughout the universe. Once the rocket lands on the moon, it then hooks up to an exoskeleton, and thereby allowing you to control an exoskeleton on the moon. You can also shoot these exoskeletons throughout the universe, and therefore be able to explore the universe mentally by shooting your consciousness throughout the universe. Now this, of course, is not possible for a few hundred years.
And living forever.
Your biological body may have a finite lifespan, unless, of course, we can figure out organic immortality, in which case we can replace organs as they wear out. So organs as they wear out may be replaced to give you organic immortality, and this organic immortality may allow you to control a robot that could then be shot throughout the universe, and you could then begin to colonize the universe, perhaps near the speed of light. All of this is well within the laws of physics, beyond our capabilities today, but I think possible.
Do you believe that we can ever create a consciousness machine?
It depends on how you define consciousness. There's no unified theory of consciousness at the present time. However, I do think it's possible to create an object that can size up its position, understand its location, understand its position in the universe, and initiate conversations with you. Is that consciousness? I don't know. There's no definition of consciousness that is universally accepted. Get a dictionary, look up the word consciousness, and you realize that there's no uniform agreement as to what it is. But I think in the future it may be possible to create a machine that is aware of itself, aware of its surroundings, aware of who is out there, and communicate, ask questions, interact with other beings. I think that is possible.
You predict that in the future we can create a second civilization, third civilization. What is the second civilization?
Well, physicists have looked at outer space for guidance as to what alien technologies and civilizations may be like. One theory ranks them in terms of type 1, type 2, type 3.
Yeah.
A type 1 civilization is a civilization that harnesses all planetary energy. Anything planetary, they control. They mine all the light that comes from the sun. They control earthquakes, volcanoes, anything on the planet Earth they control. That is type 1. Type 2 exhausts the power of a planet, and they exhaust now the power of the sun. They just don't get a suntan, they control the sun. The entire output of the sun is used in their machines. This is a type 2 civilization, and we see this in science fiction. Star Trek, the Federation of Planets, would be a type 2 civilization. Then there's type 3. A type 3 is galactic. They roam the galactic space lanes. They're able to play with black holes, and that would be Star Wars. Star Wars is a galactic civilization. That would be type 3. Then the next question is, if they visit us, are they type 1? Are they type 2? Are they type 3? Well, type 1 civilization can basically just colonize a few planets in their nearby sector of the solar system. So flying saucers probably do not come from a type 1 civilization. A type 2 civilization therefore begins to understand the nature of stars. However, even stars do not allow you to approach the light speed that we need to go across the universe. A type 3, however, may allow you to access the Planck energy, is the ultimate energy of the universe. The Planck energy is the energy at which space itself becomes unstable. You put enough energy into the Planck, you put the Planck energy into an oven, and you then begin to find that within the oven, bubbles form. Anomalies in space-time form. And these bubbles, for the most part, simply pop in existence and pop back into existence. This is called the space-time foam, invented by Stephen Hawking. The space-time foam is when you heat up a microwave oven, let's say, to enormous temperatures to the point that space becomes unstable. And then if you exceed the Planck energy, universes may start to come about. In other words, this could be the origin of the Big Bang. The Big Bang itself was a bubble that reached the Planck energy and then began to grow and give you the Big Bang of today. That would be probably the province of a type 3 civilization, which may then use it as a gateway across the universe. Well, one problem with civilizations is that they may have a tendency to self-destruct. There are basically 4 ways in which a type 1 civilization can self-destruct. You have nuclear weapons, you have germ warfare, you have global warming, and you have artificial intelligence. So there are 4 ways in which you could have planetary destruction of a type 1 civilization.
You recognize AI as a distraction power?
It has the power of all of humanity's technology, and used in the wrong way, these technologies could be self-destructive. So there are 4 ways in which civilization can self-destruct using its own technology. I tend to be optimistic in the sense that the smallest unit of history is the decade. Now, when you look at history year by year, it's very depressing. Disasters form, governments fall. So I think that if you look at history decade by decade, it is rather depressing. But when you look at history century by century, then you begin to realize, oh my God, think of the progress.
It's better and better and better.
I mean, just 200 years ago, we had the Industrial Revolution. We were dealing with steam power. We were dealing with the beginning of the Industrial Revolution for the first time in world history, using machines instead of your hands to create things. And that was just 200 years ago. And so I think that when you look at history through the lens of science and the lens of centuries, you realize that history has a direction. That history is going toward democratization. History is going toward the dispersal of technology that can relieve us of backbreaking work. And of course, the development is uneven, but the direction is clear. Technology has given us the ability to communicate, to share knowledge, and that is what the internet has done. The internet has democratized world society to the point that people that normally would be forgotten in a village and die without a name at all, these people can now communicate. They can learn. They can communicate with people around the world because they realize that their government does not have to be that way. If their government is repressive, on the internet, they can see that there are governments that are not repressive. And so they want to change. And so in other words, I think progress has a direction. So I would disagree with some people who say that science has no direction, that science can be used to destroy the world, or science can be used to liberate, but it has no direction. I tend to disagree. I tend to think that science does have a direction. And the direction is toward democratization, toward sharing of the fruits of this technology, which did not happen in the past. Now, that doesn't mean there won't be ups and downs. That doesn't mean there won't be wars, skirmishes, and problems. But when you look at history, decade by decade, century by century, you realize that there is a direction to history.
Chapter number 11, Time Machine.
Time is like a river. It flows in one direction, and it seems to be irreversible. However, along comes Einstein, who says, no, time is a river that has whirlpools. It can maybe fork into two rivers. So in other words, the river of time is dynamic. It's not just one river moving in one direction. But then the next question is, if the river of time can be altered, can you go backwards in time? Well, Stephen Hawking looked at that question and said that he thought that with wormholes, you could go forwards in time, but not necessarily backwards in time, using wormholes as gateways to another era in time. What was his argument? His argument was that if you go backwards in time, then eventually you go forwards in time, and then you go backwards in time, and you form a loop. The loop allows you to accumulate energy until it explodes. And so your time machine blows up. That was Stephen Hawking's argument against time travel. But there's a loophole in that theory. And that is, if you make one pass, not so that you make infinite number of passes accumulating energy so the machine blows up, but you just make one pass, then perhaps you don't have this problem of exploding universes, and then you can go backwards in time. This, of course, is still science fiction, but the mathematics seems to indicate that if you make a one pass in backwards in time, then you can do it, if you have enough energy. How much energy? The Planck energy. 10 to the 19 billion electron volts. That's 1 with 19 zeros after it. That is the energy, perhaps, of a time machine, the Planck energy.
To finalize our conversation, I would like to a little bit talk about you. How do you perceive yourself?
When I was 8 years old, something happened which changed my life. All the newspapers said that a great man had just died, and they put a picture of his desk on the evening news. And they said that this great scientist could not finish this book. So I said to myself, why couldn't he finish this book? If he was such a great man, then why couldn't he finish this book that was sitting right there on his desk? Why couldn't he ask his mother? Why couldn't he simply look up the answer? What was so hard? Well, I was fascinated by this man. Over the years, I went to the library, and I found out this man had a name. His name was Albert Einstein. And that book that he could not finish, was to be the theory of everything. An equation perhaps no more than 1 inch long that would allow him to, quote, read the mind of God. These are his own words. So I said to myself, that's for me. I want to be part of this great journey to read that book, to understand the theory of everything. Well, today I can read that book, and I can see all the places where he got stuck, all the places where he got lost in a thicket of mathematics. We can read that book of Einstein and realize that, yes, he was on to many ideas, but he didn't have the one paradigm. He didn't have the one image that would push the whole theory into reality. And we think that image, that paradigm, we think is a violin string. And that each violin note is a particle. And that's why there's so many particles. Why wouldn't nature flood us with all these particles with Greek names? And it's because they're nothing but different notes on the same string. It's just the same string vibrating in different modes. And so I said to myself, when I grow up, I want to begin to work on this project. So when I was in high school, I decided to build an atom smasher, a 2.3 million electron volt betatron particle accelerator in my mom's garage. So I got 22 miles of copper wire, 6 kilowatts of energy, 600 pounds of transformer steel, and I built a betatron accelerator in my mom's garage. Every time I turned it on, I blew out all the circuit breakers in the house. The whole house would be plunged in darkness. And my poor mom, she would say, why couldn't I have a son who plays basketball? Why can't he play football? And for God's sake, why can't he find a nice Japanese girlfriend? Why does he have to build these machines in the garage? Well, these machines won the attention of a physicist, Edward Teller. He's the father of the hydrogen bomb. And that was when I made contact with other physicists. These are the physicists who built the atomic bomb, and they built the hydrogen bomb. And then I began to realize the power, that this technology is not something that you simply look at over coffee. This is the engine of the universe. This is what makes the universe move. It is the engine of the universe itself. Realize that people have a thirst to understand, who am I? Where do I fit in this larger scheme of things? What is it all about? And we're flooded with all these images from Hollywood and all these images from the movies, but they never ask the question, what does it mean? Where did it come from? Why? Why is the world the way it is? And that's where I think that when presented well to the average person, they'll say, that's the reason. That's why the world is the way they are. But unfortunately, our media is driven by profit, and you make a lot more money talking about the latest movie star rather than talking about Einstein or the nature of the universe itself. But it's a way that we as professors now can reach our students at the university level. Because at the universities, we don't have the distraction of competing with Hollywood movies. And so at that level, then we can begin to engage people because they are curious. They do wonder, what is it all about?
Are you fighting with fake news about yourself?
Well, you have to realize that in a free press, people can say nonsense and all sorts of things, and you just have to live with it. That's one of the prices of being in the public domain. If you are a private person, you can sue other people for slander. You can sue them. But if you are part of the public discourse, it is very difficult to sue people.
It's too late.
Because it was your fault. You voluntarily exposed yourself to all sorts of different kinds of reputations. So it is much harder to sue people once you become part of the public domain. You just have to grin and bear it, in other words. Well, I would hope that what I talk about when I talk about science is understood, because we're talking about being able to understand and control and create a better world. That is, there's a point to all this, and that we want to change society.
Who inspired you the most today?
Well, I have my heroes, and these heroes are within string theory, and these are the people that have pioneered the mathematics of string theory. People like Ed Witten at Princeton, for example. People that have really created whole new worlds of mathematics. So even mathematicians have been fascinated by string theory, because string theory has forced mathematicians to explore new forms of mathematics. And so I think that it's interesting that a revolution in one field, string theory and physics, affects another field, pure mathematics, and gives hope that one day we'll have a unified theory of mathematics. That in the same way that string theory is unifying most of physics, it'll spin off and unify most of mathematics as well.
Which part of your career was the most difficult?
Well, one of the most difficult things of being a physicist is you have to have what is called butt power. You have to be able to sit on your butt without distractions and just go through pages and pages of calculations, sometimes several hundred pages, just to get one formula that works. And that's gratifying, because after spending hours and days and weeks going through a pile of equations, it all works. And then you realize there's something there, that this is not just garbage. There's something there, that all of these equations cancel out exactly. And that's when you say to yourself, aha, there is a rhyme or reason to nature. Nature is not malicious. Einstein would say that. Nature is not malicious. She is subtle, but not malicious. So after plowing through hundreds of pages of calculation, you realize, oh my God, it all works.
Why you agree for this interview? Guys from Poland, far away from United States.
When I was a child, reading about Einstein being fascinated by all these new concepts, I would go to the library to try to find out more about the fourth dimension, to try to find out more about intelligent life in the universe. And I found nothing. Zero. Just nothing except maybe a few comic books, but nothing about the science of what's out there, about the universe, about intelligent life. Nothing. And I said to myself, when I grow up and I become a physicist, I want to make sure that, of course, I'm at the cutting edge of research, but also I hope to convey the excitement that I felt as a child to the next generation of children. And so when children email me and write to me, they say that this is more fascinating than a comic book. This is real. This is reality. And then I say to myself, maybe I've done something, that I've touched people, and I've made them realize there's a universe out there. Not a universe of comic books or Hollywood movies, but the real thing. And that they too can be part of this great search for the theory of everything.